Hey guys, welcome to the fifth lecture in our math prep series. And today we will be tackling the concept of odd and even functions and a lot of game-changing consequences which they carry. So grab your notebooks and let's dive in. We will first start with the definition of an even function. When will you call a function even? So a function like fx equals to x square is an even function. Why? Well, a function fx is called even if fx is equal to f of minus x for all x belonging to the domain that you are considering. So functions like x square, like modulus of x, these are all even functions. Because what's going to happen here is, think about it, if you put minus 2, that is same as modulus of 2 and the value is just 2, right? So what is happening is f of minus x is same as f of x, and that is why we will call this function an even function. So essentially what is associated to an even function is the word symmetry. So essentially these functions are symmetric about the y-axis. Like, this is your y-axis. If we talk about modulus. So it goes like this, and then you can see a mirror image out here. So there's it's symmetric about the y-axis, right? And the similar kind of situation happens with x square. Which brings us to the next concept, the concept of odd functions. Now, we call a function odd if f of minus x is equal to minus of fx. So here what is happening is that it's symmetric about the origin. And the meaning of that is that a 180-degree rotation, keeps it unchanged. If you rotate it 180-degree, it will be the same. So essentially, situations like where fx is x cube. So the graph is like this and then goes like this. Sin x. So these are the kind of graphs which are odd. I think here it's very essential to understand another very important thing. Then there are many functions which are neither even nor odd. There can be many functions which are neither even nor odd. You do not have to classify every function as even or odd. For example, let me just give you an example also. If you take fx equals to x plus 1, it won't satisfy any of the thing. And the two definitions that you have, f of minus x, is it f of x? No. F of minus x, is it minus of fx? No, even that's not happening. Okay, so this is neither even nor odd, and there are plenty of functions which are neither even nor odd. Now here, I would, before we jump into, some questions to find out whether the function is even or odd, I would rather first want to tell you some very important consequences in calculus. The first one is associated to integration. So integration, simplification. You would see that for an even function, always remember the area from minus a to a fx dx, or integral minus a to a fx dx, is equal to twice of Integral from 0 to a fx dx. And this is happening because the area from minus a to 0 is the same as area from 0 to a. So it's just, because it mirrors it. So therefore, what you get is twice. For example, if you take x square, y equals to x square. And per se, if you're interested in figuring out the area from minus 2 to 2, you will see that the area under the curve here is same as area under the curve here. So you can just twice it, right? So this was graphically, but now practically how will you use it? So suppose they're asking you what is the integral from minus 2 to 2 x square dx. Now what do you have to do? If you know this concept, what you will say that this is just twice of the integral from 0 to 2 x square dx, and thus it is twice of x cubed by 3 from 0 to 2. So it's going to be 2 by 3, 8 minus 0. So 16 by 3. And that will be the correct answer. All right. And now for odd function. For an odd function, again, if we talk about integral, for an odd function, always remember 0 integral over symmetric intervals. What does this mean? Well, this means that if you are looking at the area from minus a to a fx dx, that will be 0. And that happens because, the positive area, positive and negative will cancel out and you will get 0. This is a very important, this again is a very important one, especially when you have some MCQs and all and you have to use it. This is a very important one. So graphically speaking, if x cube is the graph that you are looking at, y equals to x cube is something that you're looking at, and say we are looking at the area from minus a to a, you will see that the positive and negative area will cancel each other out and you will see that the positive and negative area will cancel each other out and you will get 0. Also, let's just take up an example that practically if I get this kind of question, if fx is equal to sine x, and they are asking you what is the integral from minus pi to pi sine x dx, what will be your answer? You will have to figure out, you will have to recall that this is an odd function. Sine minus x is equal to minus sine x. So because sine minus x is equal to minus sine x, therefore, what will happen is that the area is 0. The integral will be 0. In fact, let me just tell you why this is happening. The thing that I'm telling you, positive, negative cancels each other out. So why not just solve this integral? Let's just solve it. So, well, integral minus pi to pi sine x dx is equal to the, integral of sine x will be minus cos x minus pi to pi. So this will be minus of cos pi minus of cos minus pi. Well, so here we need the value of cos pi, which is minus 1. So minus of minus 1, even cos minus pi is minus 1. So minus of minus 1 minus minus of minus 1, which will give you basically 1 minus 1, that is 0. So this will always happen. You need to actually remember it. For odd function, if you have minus a to a integral fx dx, it will turn out to be 0. Okay, let's test a function for odd and even. Well, fx is equal to x to the power 4 minus 2x square plus 1. Is this odd? Is this even? Well, you need to check for f of minus x. So f of minus x will be equal to minus x to the power 4 minus 2 minus x to the power 2 plus 1. And well, this will be x to the power 4 minus 2 x to the power 2 plus 1, which in fact is the original function fx. So yes, this function is an even function. Look at this graph for the function x to the power 4 minus 2x squared plus 1. Can you see that there is a symmetricity about the y-axis? It's exactly replica. It's exactly the mirror image of the left and right. They're mirror image of each other, right? That's exactly what an even function looks like. Now to the same question, in case the question would have been that, okay, find the area. Find the area from minus 1 to 1, x to the power 4 minus 2, x to the power 2 plus 1 dx. Then your answer would have been that this is equal to twice of 0 to 1 integral x to the power 4 minus 2x squared plus 1 dx. And hence it is just twice of x to the power 5 by 5 minus 2x cubed by 3 plus x from 0 to 1. And hence it would be twice of 1 by 5 minus 2 by 3 plus 1. So it is basically twice of, if you take LCM, 15, 3 minus 10 plus 15. So it's going to be 2 by 15 multiplied by 8. So 16 by 15. And that would be the correct answer. All right. Now let's take a tougher example. So let's take fx to be equal to modulus of x e to the power minus modulus of x, and check whether this function is even or odd. What will you do here? You will check for f of minus x. Now f of minus x means modulus of minus x, e to the power minus of modulus of minus x. Well, all we have to use here is that modulus of x is equal to modulus of minus x. That's because this will give you just the absolute value, right? Which is the positive value of x. So if you take modulus of 2, it is same as modulus of minus 2, and we take it as 2, right? So modulus, it's the same. So therefore, this will be equal to mod x e to the power minus mod x, which is basically your f of x. Therefore, it is an even function. Now, the calculus consequence of this, in case I ask you what is the integral? What is the integral minus 1 to 1 mod x e to the power minus mod x dx? Then you will say that this is nothing but equal to twice of 0 to 1 mod x e to the power minus mod x dx. That's because it's an even function. All right. So you will be calculating twice of In 0 to 1, x is positive. So modulus of x will just be x. That is happening because mod x is x when x is greater than or equal to 0. It's minus x when x is less than 0. So our case is greater than 0. So this is nothing but integral 0 to 1 x e to the power minus x dx, which is something that you will have to solve using by parts. So using by parts, just try to solve the integral x e to the power minus x dx. So this is 1 and this is 2. So 1 as it is, integral of the second minus the derivative of the first multiplied by the integral of the second. The entire, then again integral, so dx. So x e to the power minus x with a minus sign, that's the integral, minus integral, again e to the power minus x with a minus sign, minus e to the power minus x dx. So this is minus x e to the power minus x minus minus plus integral e to the power minus x dx. So this gives you minus x e to the power minus x minus e to the power minus x. And of course, since we have, it's a bounded case, it's a case of definite integral. So 0 to 1, now you can put the boundary points. Now you can put the boundary points and you will get minus e to the power minus 1 minus 0 minus e to the power minus 1 minus 1. That is e to the power 0, which is 1. So hence you will get minus e to the power minus 1 minus e to the power minus 1 plus 1, or in other words, minus 2 by e plus 1. And well, our entire answer is twice of this. So twice of integral 0 to 1 dx of x e to the power minus x will be equal to twice of this expression, minus 2 by e plus 1. So basically 2 minus 4 by e, and that will be the correct. So what we have learned today is the concept of even and odd functions, and extremely important, the consequences of even odd in calculus, especially integral calculus. If you can remember these two properties for even odd, your integration will go very smooth. Thank you very much. I hope this will really help you guys.